Welcome back to the third question of this series where we hypothesis test the difference between two means. This time the question reads, an educator believes that new reading activities in the classroom will help elementary school pupils improve some aspects of their reading ability. She arranges for a third grade class of 21 students to take part in these activities for an 8-week period. A control classroom of 23 third graders follow the same curriculum without the activities. At the end of the 8 weeks, all students are given a degree of reading power, DRP, test, which measures the aspect of reading ability that the treatment is designed to improve. The data appears in the following table. We have to determine whether this program actually improves these scores. So here we have the treatment group and the control group. Unlike the previous questions 1 and 2, we are not given the mean or the standard deviation variance of these groups. So we have to find them from scratch. And just as before, a few formulas are helpful, the ones you see underneath here. Okay, to find the average for this group, I'll call this group 1 and this group 2. You add them all up and divide by the number. So we have 21 here and 23 here according to the question. Therefore, if you do this correctly, you should end up with the following averages. The standard deviation here, which I'll represent as S1, is approximately 11.00, and over here 17.149. Okay, now that we have the technical stuff out of the way, we can generate our null hypothesis. Now, because we're hoping to see that this group it has a higher mean than this group overall, you can begin by writing out your alternative. You can say that this group, which we'll call group 1, is greater than that of group 2. And from there we can write our null hypothesis. This is what we want to refute, that the mean here is less than or equal to the mean here. Okay, now we can go on to find out our t observed, and we'll use this formula. Of course, now we have to plug in these numbers into the formula. Let me just write it down for you really quickly. 51.47 minus 41.52 over the square root. S represents the standard deviation. It's being squared. And the relationship between variance and standard deviation is that the standard deviation is the square. So technically, we're putting this number, 11.00, squaring it, that's the variance, over n. N was 21 for that first treatment, plus 17.149. I'll just make this symbol longer. Raised to the power of 2 over 23. If you calculate this correctly, you should end up with 2.31. Also keep in mind that because this is our alternative where we are using these symbols greater than or less than, this will be a one-tailed test, specifically the upper tail. So over here. In addition, they haven't told us whether it is equal variance or not. If it's equal variance, then to find the degrees of freedom is a lot different than finding the degrees of freedom if the variances are not the same. The degrees of freedom formula for when the variances are not the same is this, and if you substitute all the values into this formula, you should get 37.9, which we round down to 37. The degrees of freedom formula for when the variances are the same is actually a lot easier. You do n1 plus n2 minus 2 would be 41 in our case, 21 plus 23 minus 2. But we will assume for the sake of this video that the variances are not equal, and we'll use this number, 37. Using the t-table underneath, 37 is located between 30 and 40, and it's a value between 1.697 and 1.684. On a t chart, distribution chart, since it's an upper tail, that would exist right here, 1.6. That's 0. The t observed value we got, on the other hand, was 2.31, and that far exceeds 1.6, 2.31. because it falls in the rejection area, we will have to refute the null hypothesis in favor of the alternative. The null hypothesis says that this group has a higher DRP than the treatment group, but that's not the case. This is the one we accept in favor of that at 0.05 significance. I didn't mention that, but the question doesn't mention significance level. So whenever they don't, just use 0.05, and that's why I used this column specifically. And there you have it. That's our third question in this series. If you have any questions, please use the comment section below, and we'll gladly help you answer any inquiries.